Hey everyone, welcome back to HackProKP. I'm Kailash Parshad and today we are diving in the world of networking with a focus on the UDP protocol. We will explore its feature and see how it works in a real-time gaming application, like a shooting game. Let's get started. First, let's understand what UDP or User Datagram Protocol is. Unlike TCP, UDP is a connectionless protocol. This means it doesn't establish a connection before sending data, making it faster but less reliable. So, what have we learned about UDP right now? We know that UDP is connectionless. UDP is fast and UDP is less reliable. Let us understand this connectionless property of UDP. So let us consider that there are two application processes. One is using TCP and one is using UDP. Okay, so for the TCP application, let us consider that the sender and the receiver are there, and the sender and receiver are going to have a formal communication between each other. This means they are going to have a three-way handshake. So first, the sender is going to send a synchronization or sync packet to the receiver. The receiver is going to send a synchronization acknowledgement packet, and the sender is going to send an acknowledgement packet or ACK packet back to the receiver. Now, this communication that is happening, this formal communication is also known as the connection building process. So, this is the connection that is actually being built between the sender and the receiver. This connection building process is also known as the three-way handshake. So, after that only the data is sent. In the case of UDP, what happens? The sender and receiver are there, so no formal communication is going to happen. So no connection building process is there. Straight away, the data will be sent. So because of this only, this is fast, but this makes it less reliable as well. Now we are going to take an example of a shooting game. In a shooting game, speed is crucial. Imagine you are playing a game where you shoot bullets. Each bullet can be thought of as a data packet. In a fast paced game, we need these packets to be sent quickly, even if some might get lost along the way. That's where UDP shines. Now let us consider that you are using this gun to shoot bullets at the target. Now we know that this particular bullet is going to be the data stream or the user data. This data stream is going to be in the form of zeros and ones, binary data. Something along these lines. So we know that this data is going to be divided into smaller chunks, smaller datagrams. Now we are going to talk about these datagrams. Now let's look at the structure of the UDP packet. It has a simple header compared to TCP. The UDP header contains four main fields: source port, destination port, length, and checksum. So, source port, destination port, length, checksum, and the actual data. Each field of the UDP datagram is 2 bytes long. Now 2 bytes is equals to 16 bits. So each of the fields are 16 bits long. So this is also 16 bits, this is also 16 bits, this is also 16 bits, and this is also 16 bits. Now these are going to be 8 bytes long because 2 plus 2 plus 2 plus 2. So 8 bytes long of data header is there in the UDP datagram. Now this data is variable, so we don't really need to care about this. The first field or SRC tells the source port number, the application process who is sending the user data. DST or destination port number tells the receiving application process, like who is going to receive the user data. LN is the length of the datagram, the total length of the datagram. This means length of the header plus length of the data. CS is checksum. Checksum is used for light error checking. Uh, this is used to identify if error have been occurred while transmission of the data or not. Now we understand the UDP data header. Now we know what will happen next. This datagram will be encapsulated into a packet, and then this packet will be transmitted to the server. The server will use the destination port number to identify the correct application process for which the data has been sent. So it will use the destination port number to identify the application process. So after that is done, what will happen? Or the question arises, why a developer would like to use UDP when it has so many flaws? To understand why an application developer would want to use UDP protocol in its application process solely depend on the nature of the application. It depends on the nature of the application because if the application process requires functionality like real-time communication, then surely UDP will be used because it is faster. And if data integrity is a thing, and we have to make sure that there is a reliable connection, then we are going to use TCP protocol. So, according to the application nature, only we can decide what protocol is suited for that particular application. So, nature of the application is the thing, the deciding factor that is going to decide what protocol is going to be used. Now, some of the reasons why a developer would use UDP protocol could be because we have finer control over what data we are sent, like a finer application level control over what data we have sent and when we have sent the data. So whenever we are using UDP protocol, whenever the data is generated, the UDP protocol takes that data, encapsulate the data into a packet, and then that packet is being sent to the host, to the receiver, straight away. With TCP, what happens? There's a possibility that congestion is there. So after some time, the data will be sent, or for example, error occurred. So that data will be retransmitted. So all of those things, because of that, there's less finer control over less finer application level control over the data that is being sent. Now no connection is established. There is no connection state, and small data packet overhead is there. We saw that only four headers are there, but TCP headers are very complex when compared to UDP protocol. So we will talk about that in the next video. Thank you for watching this video. Hopefully you learned something new. Have a nice day. Bye bye guys.